This is a lecture on absolute value problems for Chapter 2 for Math 107. Often specifications like operating temperature range or operating voltage range are written with absolute values. For example, you might see something like this. The operating temperature minus, let's say, 70 is less than or equal to, we'll say 30. Right. But you would actually like to know the specific range of temperatures. What's the lowest temperature and what's the highest temperature? Like most absolute value problems, this breaks out into two problems, which actually can be wrapped back into one. So let's look at what this means. This means T minus 70 is less than or equal to 30, because remember the absolute value pulled the sign off of this quantity inside of it. Okay, or it could be that this quantity had a negative sign associated with it, which got lost somewhere along the line with the absolute value sign. So the other half of the problem is T minus 70 is greater than or equal to negative 30. Right. I'm going to solve each of these separately, isolating the T. T is less than or equal to 110. No. Less than or equal to 100 degrees. Okay. And here, T would be greater than or equal to 40. Now when I graph this, here's what it means. Okay, here's the 0. Here's 100. And I'm just going to put down the numbers I need instead of a scale like this. Okay, for the equation, for this equation right here, this means that T could be 100 and everything down from it. All right. For the one on the other side, T greater than or equal to 40 means that T could be 40 and everything greater than it. Since both of these conditions have to hold, that means T has to lie between 40 and 100. Right, that would make both conditions hold. Instead of solving it, okay, what does this actually mean? Here's what it actually means. And you say, why would someone ever write it as T minus 70 is less than or equal to 30? Why not just write it as T can vary between 40 and 100 degrees for this particular piece of machinery? The reason is there's information right here. Okay, 70 is the average temperature. That's the one that's right in the middle here between 40 and 100. So here's the 70. That would be your average operating temperature. And the 30 means you could go 30 in this direction or 30 in that direction. That's what it means practically. And that's why things are written in this form. Because we have the less than or equal to sign here or less than sign here, we can actually write this as one problem. And the one problem would look like this. T minus 70 is less than or equal to 30 and greater than or equal to minus 30. All right, you can see if you remember the two from the previous slide, you can wrap this into one. Now to solve this, when you have a three-part equation like this, you solve it just as you did before, but you'll have to isolate the T, but the T gets isolated in the middle. And to do that, you add 70, but you have to add it to every single piece, all three pieces. So this is minus 30 plus 70, less than or equal to T. I'm writing all the steps out. Minus 70 plus 70, less than or equal to 30 plus 70, which gives you 40 less than or equal to T, less than or equal to 100. And there's your answer there, and that can be done in one step. Sometimes you can't write it in one step. Instead, you have to write the two separately. In that case, it doesn't have the meaning that it does here. The practical meaning that for this, in this case, T, the 70 is the average operating temperature, and the variation can be plus or minus 30 degrees on either side of that 70. It won't have that kind of physical significance, but you can still solve the problem. Here's a problem that cannot be wrapped into one equation with three parts. Instead, it has to be done separately. Say we have 30y plus 20 absolute value is greater than 50. Right. To solve it, we break it into the three pieces. 30y plus 20 is greater than 50, or 30y plus 20 is less than negative 50. When I solve this side, I get y has to be greater, whoops, not greater than or equal to, y has to be greater than 1. And when I solve the side over here, y is less than, let's see, minus 2 2/3. Here's what the graph looks like. It has two pieces to it. I can get this line straight. Okay, here's 0, here's 1, minus 1, minus 2, minus 3. Okay, to graph this part, y is everything greater than, strictly greater than 1. On the other side, y is less than or equal to minus 2 2/3, which is somewhere in here. And so it does have two parts. There's no overlapping part that gets eliminated. That is the solution. If you want to write it in interval notation, minus infinity up to minus 3, then you eliminate everything in between, start at 1, and go to infinity. This problem cannot be wrapped into one three-part problem like the previous one, but instead you just solve it each side separately and then get your answer from there.